I was trying to figure out how enchantment worked in my theory of D&D magic, and that led me to develop a new update to the broad theory of magic. And let me tell you, I got way too into the weeds of this. First, let's talk about spells in the original theory of magic. Now, in the original, we thought of spells as these two-dimensional kind of bumps in a magic field, with those two dimensions being the damage space and the space. So this is our X direction. And if the spell moves in the X direction, it'll get a little bit thinner as it approaches its range until it's infinitely thin here. Basically, that's how we formalized the idea that you will never be able to cast a spell beyond its range. Without extra stuff, let's not get into that for now. Basically, what this means is this bump would stay the same in the damage direction, but it would move in space. And so when the spell hits its target, that's you kind of make a hole in this magic field to allow the energy through, and then you randomly sample from these Gaussians. So you might end up with a random bit of space, but that's okay because this is very small compared to what you're hitting probably. And then you get a random kind of damage as well, and that's where the dice rolling comes in. Now, in the new theory, we're going to basically do the same thing, but we're going to steal from quantum mechanics, and we're going to think instead of a spell as a propagating wave packet. What I mean is that the wave moves like this, so it is this purple wave, and this red line is the Gaussian bump we saw before, but now we're looking at this instead. And interestingly, we can add in the same range parameters as before. So I'm really sorry if this is very complicated. I'm fully just geeking out on my idea right now. The reason this is cool is because now we can more formally define that the wave equation, whatever that is, I haven't actually figured out the specifics of the wave equation yet, which feels important, but we can say that it is now defined such that the damage distribution, the damage probabilities, and the spatial ones all match up to this waves if we were looking at it from a more quantum perspective. Yeah, basically we're looking at quantum magic theory. The idea being that your spell is in this wave, and as it moves, when it gets into the target, when it has to come through, it will collapse into somewhere on the damage and the spatial axes. Now, this isn't exactly quantum mechanics, and I think for the sake of simplicity, I'm going to have to avoid falling into just doing quantum mechanics. We'll do the classic and say that we leave it as future work. This is where it's important to remember we're making a theory of magic. It isn't actually real. When making these theories, I take a huge amount of inspiration from the real world of physics and astronomy, and that means that we can play a little bit loosey-goosey with some of the rules of physics. I think of it like this: we start from a perspective of magic, we then create a model and we do all this nice physics and maths that's all very consistent and could work in the real world provided this was true. Then I'm probably going to do some hand waving that basically goes, it's magic, I define this as it is, and then from that we can move on and do some more proper physicsy like stuff and then apply it back to the magic world. That's okay. Let me know if you have any ideas, but I'm very interested to see how this develops. Anyway, have a lovely day. Okay, bye.